Make sure that takes. We are recording, just for the record. I want to say that we are recording, and you can also, if you don't want to talk by raising your hand, you can put your comments, questions in the chat feature, which is like the little cartoon bubble you see there. And if you'll click on that, you can address the group or each other even in that function if you prefer not to raise your hand and be called on. So there are multiple ways we can communicate, participate, and I will call on as many of you as possible and get as many of those answers if is possible. And if we do have some questions we can't get answered, we'll do our best to respond after the meeting. So the meeting agenda, we want to call on Vice Chancellor Sandra Noisa. She just wants to give her greetings and well wishes. And then we'll introduce our special guest for today and have a guided discussion with him. I encourage Q&A, and you can do that at any time. We're going to ask our guest a series of prepared questions that he's prepared answers for. And so you can at any point raise your hand if you have a question about, if you have a comment or question about the topic at hand, or we can also, and we will also have another Q&A session toward the end where you can share what you want to share or ask any additional questions that you might have. So with that, I'm going to call on Vice Chancellor Noisa to give her welcome and comments. Sandra?
Thanks, Greg. I'll be brief because I know we've got a lot of great information to cover this morning. And first of all, I want to thank everybody for participating, and also just for the hard work that you and your staffs are doing every single day. To Greg's point, our mission as facilities professionals is challenging under normal circumstances, and this year it's certainly harder than ever. Some of you have had students back on campus for a few weeks now. Others, it's been just a few days. And I think we all know that over the next few months, we're going to have many, many lessons learned. We'll have some successes, and no doubt we'll have some failures. And so I encourage all of you to continue to share your experiences, to seek solutions together, ask for help when you need it, and most importantly, to stay focused on the long term. We'll get through this. Our mission is to provide functional and safe places for students, staff, and faculty to work, learn, live, and sometimes play on our campuses. And you know, we will get through this, and really appreciate everybody's participation and willingness to share. So that's it. And with Greg, I'll turn it back over to you.
Thank you, Sandra. I appreciate that. So with that, I've got a couple of things that I want to recommend to you. These are some webinars. Of course, we may all be kind of webinared out at this point, but these are several that I thought were very high quality, and they deal directly with the topic that we're discussing today, which is more centered around HVAC modifications to address COVID-19. Kind of do's and don'ts and recommendations from our guest, our professional engineer. So the first two webinar links there deal with those aspects. One of those, I think it's the second one, has one of the guests is Taylor Engineering, and they have produced an excellent white paper. So I have embedded that white paper in the chat box if anytime during this session or afterward. If you want to return to the chat box and just scroll all the way up to the top, you have both the links that you see here in the chat box, and you have that white paper that you can download from Taylor Engineering. Great resources if you want to do a little deeper dive into this topic. And then the bottom one is a EPA webinar, and it's very high quality, very technical, very scientific, but I think it's a great contrast because it addresses a lot of the leading edge research that's being done. It's also very theoretical in nature. So they propose some models and some theories about, does how SARS and COVID-19 spread, and do they spread through HVAC units and that kind of thing. And it's a good contrast because it's very theoretical, but the other two kind of address where the rubber meets the road, and is there any empirical evidence as opposed to the theoretical as to whether those things actually happen. So quality resources, I recommend them to you if you want to do a little bit deeper dive there. With that, I want to introduce our special guest, Dale Hiring. He's a professional engineer with Nottingham, Brook, and Pennington. Many of you know Dale, and most of us have worked with Nottingham, Brook, and Pennington. We really appreciate Dale and NBP allowing him to address us today and taking the time to do that. Dale received his Bachelor of Mechanical Engineering from Mercer University in 2001. And joined NBP soon thereafter. He became a registered professional engineer in 2006, an associate of the firm in 2008. He is a lead accredited professional and has served as principal of the firm since 2015. Dale is highly proficient in building HVAC load calculations, new system design, and system renovations. He has extensive facility experience with educational facilities, recreational facilities, laboratories, and religious facilities. Dale, we really appreciate you being here today. And with that, I'm going to ask you the questions, and you can take it from there. I just mentioned some resources some good go-to resources. Do you have any go-to resources that you can recommend for our participants today?
Yes. Hi, Greg. Thank you very much, first off, for allowing me to join you guys on this. As far as resources, the most used in my folder is the ashray.org website. And over the past several months, almost weekly, they've been adding updated material to their site, specifically related to COVID-19. So if you go into ashray.org, on the front cover there, they'll have a COVID-19 banner at the top, and then technical resources after that. And they jump in pretty deep. They under technical resources, they've got guides for reopening, for closing buildings temporarily, topics of filtration, disinfection, transportation. So they cover COVID-19 pretty thoroughly in there.
Excellent. Well, thank you for that, Dale. What measures are you seeing your clients take to maximize their system's effectiveness against COVID?
Well, we're seeing sort of everything across the board, and I guess I should start with owners first. They need to start at the room level. I know lately HVAC has been sort of a hot topic. But even ASHRAE emphasizes right at the bat that COVID needs to be addressed initially at the room level. So be it social distancing, increased sanitization, masking, that sort of thing. And then HVAC comes in secondary. At the HVAC level, I then have to look at existing buildings versus new buildings. And ASHRAE dives into both of those at great depth. But in existing buildings, we start with turning off demand control ventilation. For years now, code has mandated that demand control ventilation sequences be put into buildings. And now with COVID, they're asking us to turn those off. Demand control ventilation basically allows you to decrease your ventilation air in a building, and that is the opposite of what they actually want to be happening right now with COVID-19. Then extend the HVAC air system runtime, and by that I mean in occupied mode, which allows your outside air dampers to be open. That helps increase ventilation and almost sort of flush the building while no one is in the spaces. Review your energy recovery devices to ensure that you've minimized crossover between your airstreams. Review potential for increasing filter or MERV ratings as we typically know them. Right now, ASHRAE is promoting 13 as sort of a minimum MERV rating in air handlers. The consideration for ultraviolet, or as ASHRAE also includes evidence level B technologies. That would include your bipolar ionization devices, photocatalytic oxidizers, electrostatic filters, stuff like that. And consider implementing reset economizer sequence. And a lot of buildings have been installed over the past 20 years or so with economizers in them, but they've basically been an on-off type deal. With a reset economizer sequence, what it does is it modulates the economizer to get as much outside air as you can, while still maintaining an appropriate discharge air temperature to keep your humidity under control. On new buildings for HVAC, you need to have your design team design for more MERV 13 or 14 where possible. Design above the ASHRAE 62 ventilation rates. That's one of the big ones they're really pushing right now. Is ASHRAE 62 establishes a minimum ventilation rate for all of your occupied spaces, and for the most part, designers have sort of used that as, well, that's where we design our ventilation rates. Well, ASHRAE is now coming out saying, hey guys, keep in mind these are minimums. We would like you to see now at about 150% of the minimum ventilation rates. Implementing active dehumidification and consideration for humidification, which is something that we don't really think of a whole lot in our buildings down here in Georgia. But ASHRAE and CDC have all come out now and recommended that we try and maintain our building relative humidity between 40 and 60%. And in the winter, especially with increased ventilation rates, that bottom end can fall out below 40% without humidification. So something we need to consider. Consider adding ultraviolet to your design, be it at the room level or duct or air handler mounted. Set your hours of occupancy for a minimum of 2 hours before and after building occupancy, and that is straight from ASHRAE. In fact, they update these things. I guess now it's about weekly, and I just noticed that this past week they've now come out and suggested that building automation systems go into an occupied mode 4 hours before the building becomes occupied. So that has changed here in just the past few days. Utilizing reset economizer again, and if increased ventilation and ultraviolet are not desired by the owner or the users, I recommend you strongly consider some of the other evidence level B technologies. Again, that's your bipolar ionization, your oxidizers, electrostatic filters. And note that most of these technologies meet ASHRAE 62 requirements for decreased ventilation air. A lot of these technologies were used in the past to allow designers to decrease the amount of ventilation required into an air system, but you don't want to do that. You want to maintain your standard ventilation rates and then supplement with this technology. So those are the type of things that we're looking out for.
Great, Dale. And you mentioned demand control ventilation. That's one of those strategies that you talked about that mainly helps you decrease the amount of outside air that you have to take in, right? That's mainly an energy saving strategy. Is that correct?
You're absolutely correct.
Right. And I think, it kind of goes without saying, but the health and safety always kind of take precedent over energy savings. It doesn't decrease the need for energy savings, but that's just an order of priority. So that's why we would reduce that demand, or eliminate that demand control of ventilation and go with different strategies.
That's correct. And you can talk to your building automation folks, or a commissioning agent, or your design professional about it. That there are several different means of accomplishing demand control ventilation. Um, um, we do it in two different places. You can do it at the room level, where if you start to see CO2 levels increase, at the room level, you increase the airflow. And inherently, you are thereby increasing the amount of outside air introduced into that room. Second, you can monitor your spaces or your return air for CO2 levels, and adjust the amount of outside air being drawn into your system.
And you talked about hours of operation. I know early on the recommendation was from some sources and some ASHRAE members, not necessarily from ASHRAE itself, but to run 24/7, and that's not the current recommendation, right? It's the, as you say, it changes, but it's 2 hours before and after occupancy, and now maybe has gone to 4 hours before and after. Is that right?
That's correct. Like I said, they all these different organizations are almost daily coming out with new stuff, and what they're trying to do is like I was describing earlier, sort of flush your spaces before and after occupancy.
Great. And could you just talk a little bit about so folk will know about the level of evidence? You mentioned B level of evidence. What are those about, and what levels are there?
Right. So when ASHRAE is looking at these different electronic, what we call filtration devices, such as ultraviolet or bipolar ionization, they have evidence level A, which is stuff that has been thoroughly vetted over years and years of testing, not only for surface decontamination, but airborne decontamination. And then they have level B, which is stuff that has come out. It probably has third-party testing results, which shows it to be effective on certain strands of virus or bacteria, stuff like that. And but ASHRAE doesn't have a large database from which they can look at stuff and say, okay, look, in an airborne environment, this device is effective at X wattage or X particles per million or something like that. So they sort of tend to gather that stuff into what they call evidence level B, which means testing by some laboratories shows it to be effective, but we can't say exactly how effective.
Super, thanks for that. Are there, it sounded like that you just talked through a lot of measures that people are doing. Are there any other measures that you're recommending to your clients, or does what we just talked through, is that pretty much what you do?
Well, the first thing I recommend is that owners do something, and that should be pretty obvious, I think, to most folks. But if you walk around nowadays, you'll see there are a lot of people who are scared. They've been in their house for 4 months, and now all of a sudden they're being asked to be introduced into a potentially larger groups of people, and they're worried about it, be it a reasonable worry or not. They still are. So we need to try and address that with some of these folks. I would recommend starting at the room level with signage, letting occupants know that you have their safety in mind, and you're actively attempting to minimize their exposures. Adding sanitation stations, getting aggressive with surface sanitation, that type stuff. Sanitization, I apologize. And then reach out to your design engineers, your controls folks, and other active partners that you have in these facilities to discuss, your desired HVAC opportunities, and then what are realistic opportunities for those different buildings.
Great, and we have a couple of comments and questions that have come in. Dale, James Grigg with Augusta University notes that in the Taylor Engineering white paper that I referred to, it talks about ozone production with some of the evidence B devices that you just talked about. Is that a concern, and why?
It is. Ozone is one of the monitored items that ASHRAE asks us to look for, and they do have recommendations on what levels of ozone people should be exposed to for a healthy environment. And what you don't want is, in nature, there's enough occurring ozone. We don't need to be adding to that actively with some of these different electronic devices. So it's hard for ASHRAE to come out and say, hey, watch out for ozone, and then come right behind it and say, use this ozone producing device inside of your building. But most of the technologies are pretty honest up front in their advertising material as to whether they do or do not produce ozone. So I've not really seen much of an issue with that. And some of the technologies, such as bipolar ionization, they were a big culprit of producing ozone. And I know at least 2 of the manufacturers have come out with bipolar ionization equipment, which does not produce ozone. So it is out there.
Thanks for that. And Ron Reed with the Office of Real Estate and Facilities asks, can the mechanical engineer model the increase in O&M costs associated with HVAC COVID enhancements, whatever they might be?
Yes. I guess it depends on how far you want to go. We can model your whole building and add the additional 30 watts per square foot of coil for ultraviolet or whatever, or your added static pressure, but they should be able to roughly approximate cost of any added devices you might be looking at in your building.
Great. Are there measures that you wish your clients would do more of?
I think we've sort of walked through most of those. The doing something, the getting active in your occupied spaces, and then just reaching out to your design folks to figure out what you can do in these spaces. A lot of times what we'll get is a single building. We'll just focus on one building, and I think that you've really got to look at this stuff campus wide, because that person who might be in your chemistry building at the moment is eventually going to walk over to your cafeteria or to your gym or to some of these different places, and you've got to sort of keep that in mind as you look at your approach.
That's a great point, Dale. And there might be some buildings that you really can't do some or many of these things in, that you want to consider moving activities and occupancy out of into ones that you can, I imagine, right?
That's right.
Okay. All right, which of the measures that we've talked about do you consider of highest value, I guess, with highest value in terms of health and in energy savings?
Right. Well, it sort of depends on who you're looking at. From the occupant's standpoint, it appears that signage is the biggest benefit. They want to see stuff. A lot of people's anxiety or fear, if you will, tend to fall off if they see that something is happening, or they're at least informed of what is happening. To the owner, working with your facility folks and design professionals to determine which strategies are realistic That to me is the highest value action to take.
Are you able to perform all of these measures that we talked about in all systems?
The recommended measures, no. And for example, most buildings utilize central station air handlers, which are large enough or have the capability to include ultraviolet, MERV 13 filters, humidity control. But for small equipment such as small fan coils and the like, that you would often find in dormitories or small office spaces, they're not capable of ultraviolet. They don't physically have the space, or MERV 13. They don't have a powerful enough fan motor to push through the additional static of a MERV 13 filter. So you've really got to look at it all in a case-by-case scenario. Going out and buying a bunch of MERV 13 filters and saying, I'm just going to put them in all my buildings, might not be realistic. Right. Hey, Greg, did we lose you there?
I'm sorry, I was muted. We're frequently marketed in our various roles of the stakeholders that are on the call today by companies that are selling various air treatment technologies, or whether they be in the central systems or room level systems, room levels. In what situations should these technologies be considered? And could you walk through some of the most popular ones? You've alluded to the especially the air treatment technologies.
Mm-hmm.
Could you walk through what those are and maybe the pros and cons of each, and in what situations they should be used and deployed? And do you have an idea of the life cycle costs of those various technologies? I know that's a lot to ask in one slide, but we'll let you take a crack at it.
Right. ASHRAE speaks to these different technologies, and in short, what they say is if third-party testing for use against COVID-19 is provided by them, they should probably all be considered on some level in lieu of not doing anything. If you can't get in MERV 13, if you can't get in ultraviolet, if you don't have the ability to increase ventilation, go ahead and look at some of these different technologies. Talk with your design professionals or your contractors about what's out there and what they can do, and what would be applicable to your particular system or building type. And it truly is a case-by-case scenarios. As for the most popular, I can tell you the calls we get, I would say 80% of them are about needle point bipolar ionization. Probably another 10% are about mobile filtration devices. And then everything else is in that last percentage there. The bipolar ionization devices, ASHRAE has not yet verified the efficacy of bipolar ionization in air systems, but they have stated that they do agree with a third-party test which show efficacy in closed system laboratory testing. So they do they are effective against viruses under certain conditions. Is it effective under all conditions that they can't yet speak to? The mobile filters, and that includes HEPA filters, UV filters, or combination HEPA and UV filters that are portable around different occupied spaces. they're proven effective just by the nature of their technologies, but their effective range and usage times depend largely on how the owner deploys these type devices. So those are the two biggest ones, and some of their drawbacks that you have to consider. As far as total life cycle cost of each, the life expectancy is largely manufacturer by manufacturer on the electronic devices. And I hate to say it, but you do have to keep in mind that a lot of these manufacturers are new to the market and are trying to capitalize on opportunity. So if it's a new piece of equipment that's never been out there, you may have some issues with the reliability. The ultraviolet bulbs, what we typically see is that they begin to lose effectiveness after about a year or two, which means you have to replace the bulbs, not the entire UV assembly, but the bulbs. So you do have to purchase those on occasion and keep some on stock. High efficiency filters, they will load quicker than low efficiency filters. But that being said, their life expectancy really depends on several different usage factors, and that is how long you're running air through the filter, if it's 24 hours a day or just 3 or 4 hours a day, the quality of the air you're pulling through the filter, and if you're using a pre-filter. Usually when we're dealing with a MERV 13 or 14 filter, we recommend that you have at least a MERV 7. We advise for a MERV 8 pre-filter, just to help extend the life expectancy of those higher efficiency filters. They're expensive, so going in and replacing a MERV 7 or MERV 8 filter for a couple bucks every month is a lot cheaper than a $20 MERV 13 or 14 filter every month.
Great, and I think a lot of this, your comments just now point out the fact that it's really a room by room analysis, right, of how effective it's going to be in that area, and then the cost analysis that goes with that. And to your point about being new to the market, a lot of these technologies, I was talking to a university here last week that ordered a bunch of I won't say which one, but they ordered just 1,000 or so of some of these room treatment devices, and just couldn't get them. I mean, the supplier just couldn't make it happen on the promised delivery, so they're delayed past the point where students are moving in. So a lot of things happening out there in the marketplace, and so it's something to watch out for. I don't know how you get those assurances that the devices will be there when you try to order them, but that is a problem that's presenting lately.
You're 100% correct.
So we've talked about system level modifications, and we've talked about area level treatments. What's the right balance between those two?
That truly has to be determined on a building by building basis, or I'd go even farther. I would say it's on an HVAC system by HVAC system basis, because a lot of times these buildings have multiple different air handler types, and you've truly got to look at each one of them individually. A lot of time it's going to come down to where can we actually physically and financially accommodate these available resources. This stuff all occupies a space. Some devices are smaller than others, but they do have to go somewhere. So when you're looking inside of a room, they have an upper air device that uses ultraviolet to create a layer of ultraviolet light exposure above the occupant's head. Well, if you're in a space that only has a 7-foot tall ceiling, you can't really do that. They want to see like 7'6" is your minimum height on those things, preferably up to like 10 feet. So where can you physically locate some of these things? Second, a lot of this stuff is very expensive. So you got to sort of consider the cost impact of if you're looking at an ultraviolet system for an air handler, you could be talking $30,000-$40,000, as opposed to if you say, well, we've looked at the evidence level B equivalent, let's say bipolar ionization or something along those lines, you might only be looking at $15,000. So depending on where you are and what you can afford, that's something else you have to consider.
And you spoke of UV light. I know, system versus room level. UV lights are great for keeping coils clean and keeping growth out of the inside, but they might not necessarily be great at killing, even though there's not a lot of evidence yet that the COVID virus is being passed through returned on a central system back to other spaces. But if it were, UV lights might not be the best way inside the system to treat them because of the contact time it takes to kill the virus. Is that right?
Yes, and I'm glad you brought that up. I know we don't have a slide on it, but it is definitely something to keep an eye out for. We've had several owners come in with quotes from contractors, and they say, hey, we're trying to address this COVID-19 issue, and we're trying to do it with ultraviolet. That's the technology we've chosen. And here's a quote from the contractor. And the quote references coil or surface cleaning ultraviolet array, and they typically run at about 7.5 watts per square foot, which at 7.5 watts per square foot is appropriate to clean a coil, is appropriate to clean the surfaces inside of the air handler. But that dosage is not appropriate to kill airborne viruses. To kill airborne viruses, you're going to be in the neighborhood of 15 to 20 watts per square foot. So double, almost triple what you would get if you were just trying to size a UV system for coil and surface cleaning. So you've got to be aware of that as you're looking at this, and that's where I really push working with a design consultant of some sort to watch out for some of these little pitfalls.
And to your comment about it's sometimes a system type by system type analysis. Also, we've got a kind of very interesting question by Dane Richards about chilled beam. Could you talk a little bit about chilled beam? You might have to explain what chilled beam is briefly, and then are there any different considerations or variations for COVID enhancements or not with chilled beam systems?
Well, so just a little information on that. Chilled beam is basically where you bring a hydronic source that has been cooled, not quite to condensing temperature, but is cold, and you have a coil in a ceiling mounted configuration, and then you blow a little bit of air over it from your air handling system, or typically a DOAS system, 100% outside air system, and it induces a Quanda effect, which basically creates a draft through there, thus providing cooling and ventilation in the room itself. I have not seen any technologies being applied directly at a chilled beam module, and so I would think maybe they could put in a small ultraviolet tube or something like that, or a needlepoint bipolar ionization module in it. But I've not seen anybody from any of those technology groups talking about that. However, you could look at your DOAS system and start looking at how you could potentially address any issues at your DOAS system. A lot of times they'll use energy recovery on those DOAS systems. So you need to make sure you don't have a lot of leakage or anything like that at like a energy recovery wheel or something like that. You could look to employ a higher MERV rating filter on your both intake and exhaust, because if you do have energy recovery, if there's any viruses in your exhaust air, you don't want it being transferred over to your incoming air. So that's where I'd probably look at doing something like that, and then consider increasing your ventilation. If you've got a chilled beam that can handle 70 CFM, but the design has it only operating at 60, you might want to look at maybe trying to see if you can turn up to your chilled beam device maximum.
And by DOAS, you mean dedicated outdoor air system, right? That's often used.
I apologize. Yes.
Often used to introduce outside air because some of your chill beam systems don't have a source for outside air, and you just introduce that required minimum outside air through a separate system, basically, and that's your DOAS. But it's a fascinating consideration because some of your ASHRAE recommendations address the heat recovery that's often inside of a DOS, which recovers some of the heat from the intake, the ingoing and the outgoing air streams, and there can be crossover in those airstreams that might be another consideration for COVID.
Yes. In fact, when this first came up, ASHRAE took a little bit of time to catch on to, hey, we need to say something about energy recovery, more specifically wheels is what they were looking at. And then when they did, they initially came out and said, just turn them off. And literally 2 days later, they took that off and they said, whoa, we sort of, stuck our foot in a little bit on that. Don't turn it off, but look at it and consider what you need to do with that.
Well, all the disciplines have done some double takes on this. We're learning as we go on this one, right? It's a new beast that we haven't really faced before.
That's correct.
The webinar I referred to in the earlier slide promotes using a team approach to modifying HVAC systems. That team, the team recommended, would consist of engineers, building commissioning agents, and test and balance technicians. What are your thoughts on that approach?
Controls vendors and HVAC contractors, I think, should also be active participants in this grouping. But otherwise, yes, I agree with this approach. I would recommend that you start with your preferred design professional and have them review design building documents. Especially, I guess I would speak to existing buildings at this point, but looking at existing as-built drawings, test and balance reports, commissioning reports, the O&M manuals, and then don't forget building automation sequence of operations. That's a big one. But talking with your design professional about realistic opportunities, which will probably from there lead to working with the other described partners. And like you mentioned earlier, ultraviolet and MERV 13 and MERV 14 filters are in extremely high demand right now. So it would probably be wise to put your local vendor of your preferred UV or MERV filters into that role as a critical role as well.
Our campus facilities folks are often in the position of having to respond to multiple stakeholders, and that's right and good. That's what we do. That's what we're here for, right? But sometimes different stakeholders have heard of different applications, different technologies, various technologies or modifications that should be made to the HVAC system. For example, early on, that we've already talked about the recommendation that got out into the wild, to run 24/7, and so a lot of stakeholders adopted that the stance that they wanted everything to run 24/7, which is not was never really ASHRAE's recommendation. Or So do you have any advice for the folks that are running these systems and responsible for these systems about how to best respond to various stakeholders that might not have a full grasp of how the systems work?
Yeah, keep in mind there are lots of opinions out there on how you, and I say you as a um, the facilities personnel or owners should address COVID. And there's not a whole lot of real data on how to best mitigate all the potentials for exposure. If you talk to 20 people in a room, you'd get 20 different um, requests on how you should handle this. But start with the basics. Notify your users early that you're working on some practical solutions. Let them know if you're working with design professionals or your controls folks. Utilize signage to inform your occupants, and then act and let them see that you're acting. When this all first took off, my initial thought was, man, ultraviolet is going to be a real premium in air handlers. But then seeing sort of the public reaction to everything, I've sort of changed in that the room-mounted upper air ultraviolet or room filtration devices or room bipolar devices, any of that stuff has sort of moved its way to the front, because not only are you doing something, you're doing something in front of people so that they see you're doing something. And I feel like that has really become of huge importance lately.
Yeah, I kind of went through the same progression transformation too about the room level devices. However, as you noted earlier, there can be other considerations just besides cost and efficacy. For example, noise, like the air filtration devices that you put in a room or a classroom can be noisy, right? And can
Yes.
be a nuisance. UV light, very effective, I think. We can say that at the room level when applied right. However, a lot of people are nervous, about being around UV light, even though they're designed not to hurt people. It can increase the nervousness of building occupants. And I guess that's why you have to be so careful to communicate what you've done and how you've done it, and the fact that you've taken their total health and well-being into consideration, right?
That's right. And a lot of these companies who have these various products, they'll offer signage as well to say, here's what is installed in your building, here's how it works, here's how it protects you. So don't be afraid to talk to these folks about that material.
Good point. Good point. How are the design specifications changing for new systems as a result of this new world we're living in today?
At the higher ed level, honestly, not very much. The state has promoted high efficiency MERV 13 filters for years now, central station air handlers with cold decks, building automation systems. All that stuff has been around for a long time. And as design professionals, we've been utilizing it for a long time. Energy code already mandates that most buildings have economizers or demand control ventilation. So we've run into this type of stuff before. And some, I would probably go as far as to say most institutions have already implemented UV arrays in their air handlers or MERV 13 filtration, MERV 14 filtration, increased ventilation. So we see that. And engineers who've been working on your higher ed buildings will most likely have already run into most all of this stuff over their career.
Great. Well, with that, we're going to open it up for questions. We've had some great questions so far. I don't see any in the queue, but here's your chance. You've got a professional engineer on the line, and here's your chance to put him on the spot. If anybody would like to present some more questions, you can either raise your hand or use the chat box, and we'll get Dale to answer those questions in the remaining few minutes that we have. So not seeing any yet, but don't let that stop you. Don't let that stop you from, if you thought of some or think of something new, raise your hand or put a comment in the chat box. Otherwise, I just really want to thank Dale for taking the time out of his busy schedule and being with us today and giving us such an informed and detailed perspective and an overall perspective too, because a lot of what we get is piecemeal and this application and that application. But I think, Dale, you did a great job of giving us a good broad overview of how we should approach these things, and I really appreciate that.
Oh, I appreciate the opportunity. Thank you.
Yes, sir. I'd also like to invite, at this time, we've got about 6 minutes left, any information exchange, anything you've done at your institutions that you would like to share for the good of the others in the group. Anybody have anything that they would like to talk about that they've done in their HVA systems and their COVID responses on their campuses? I'd love to hear from you. If you're willing to do that, please raise your hand, and we'll call on you. I'll go back to the previous slide. I also always like to solicit your thoughts, your comments about these meetings. Are they useful? We want them to be useful. We want them to be a good investment of your time. Would love to have future topics proposed that you would like to have as the subject for these types of meetings. If so, please either send them to me at the email address, or I kind of even like doing it the old-fashioned way. Let's just get together on the phone and talk about it and have a great discussion. Be happy to talk to anybody about future topics or topics of interest. So with that, I don't see any hands raised or any questions. So we are drawing very close to the close of our session. So with that, I'll thank everybody, especially Dale, but I want to thank every one of you that attended, and the great discussion and the great questions that you presented. And just look forward to the next time, and give me a call if you need us at the system office, at the Regents office, the Office of Real Estate and Facilities. We stand ready to assist you any way we can in your COVID response and the other things you do every day. We thank you for that. We appreciate that. So I'm gonna sign off now, and thanks again.